All right, it says John scored a 75 and 86 on his last two tests with a W, probably. He is taking his third test today. If after this test he has an average of 85, he gets to go to Florida for the summer. What grade does he need to get on this exam so he can go to Florida? Labib. He has to get at least a 94, right? He can get a 95, a 96, and 97. Now, how you do this, maybe you just did trial and error, but the correct way to do this is, first of all, how do I get the average of two tests? Yeah.
Plus and divide by 2.
Divide by 2. How would I find the average of 3 tests? Yeah.
You add them all together and you divide by 3.
You add them all together and divide by 3, but we don't know one of our test scores. We have 75 plus 86 plus x divided by 3 needs to equal at least 85. So when I'm solving this, I would just multiply both sides by 3. And we would end up with 75 plus 86 plus x is going to equal 255. Well, if I take and subtract 86 and 75 from both sides, we're going to end up with x equaling 94. So you should have came up with 94%. Questions on the bell work? All right, for homework, you may have heard me describe, we were going back and forth on number sets and stuff, and I didn't really change my answers, which I probably should have. So some of the answers on the answer guide were, in fact, incorrect. Let's go over the ones that I caught were incorrect. So let's go ahead and look at lesson 2, measurements of center. If there's another one you think is wrong, just let me know. First one, number 10. Number 10 should have a mean of 15.6. and a median of 9.5. Does that match what most of you have? If you didn't change it, awesome. Number 11, the mean should have been 17.27. It should have been 17.27. The rest may have been correct.
That was the mean that you changed?
Yeah. So the median should have stayed 17, I believe. Is that correct? Oh, we had different answers? Yeah. Oh, okay. Yeah.
Question for number 18.
Oh, yeah. Let me go to all the changes really quick. I'm going to go through all the ones that I'm making sure you have them correct, and then we'll go over questions on what I did and how I did it. Why is it in your locker? Okay, yeah, go get it. Number 18, the max should be 45. The max should be 45. I believe the rest are correct, but we'll go over that in a second if we have questions on stuff. All right, those are the ones I caught. What questions do we have? Krupa. Shh. Guys? 18 would have no outlier. Hang on, it would have an outlier because it would have 45. 45 would be the outlier for number 18. That was a set before. We included 45 to be an outlier, but then I put it on the bottom and I didn't use it in the max. So yes, it would have an outlier and 45 would be the outlier. For number 18, if we weren't talking... Oh, that wasn't you. I thought it was EJ. So for number 18, first change is max should be 45. And the second thing, outlier does have an outlier, and outlier would be 45. Yeah. Yeah. Okay, then let's go over number 11. That's what this part is for. All right, number 11 is a frequency table. It is a frequency table. So what we have to recognize... Ooh, that's super blurry. You guys can see that, right? Cancel. So number 11 is a frequency table. So although it's 2, 7, 12, 17, 22, 27, 32, 37, 42, 47, these numbers actually appear a whole bunch of times. This data set has 2 12 times. So if I was to write all these out, it would be 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 12 times. And then it would switch over to 7, and it'd be 7, 7, 7, 7, 7, 16 times. And then it'd be 12, 16 times, 17, 16 times. All right. So we actually have 94 data items, guys. Do we need to sit somewhere else? You guys just keep whispering as I'm talking. Okay. So we have a total of 94 data points. So if I would have listed this all out, I would have had to list 94 of them. Okay, kind of like, let's see if. So if you look at 10, 10 has 1, 2, 3, 4, 12 data items. This one would have 96. It would take forever to write them all out, so we write it as a frequency table. Now to come up with our mean, we need to add all of these together and divide by 94. Well, I can't just go 2, 7, 12. I can't just add these top ones up because I have to add all 12 of these 2's together. So that's why I did 2 times 12. That's why I did 7 times 16. I did 12 times 16, 17 times 16, 22 times 10. Added those all up, divided by our 94, and we ended up with 17.27. This is one of the ones that you probably want to do your median and find what number you need to go to. So our central point would be n plus 1 divided by 2. That'd be 95 divided by 2, which would be 47.5. Now I'm just going to count, well, this is 12, 16, 16, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 30, 40, 50, 60, 70, 28, 34, 35, 36, 37, 38, 39, 40, 41, and you'll see that 47.5 is actually going to be right here. Does that make sense on how to tackle that type of problem? All right, good. Yeah.
For number 18, I don't know, for, what did you get for Q1? I said you got 28.3.
For number 18, I got 28.3.
I don't know, I had different answers to this, like I have 28.25, and I don't know if like you rounded, and then my answers are...
I rounded to the nearest tenth.
So then mine are...
You're 100% correct.
Is that okay? Then?
Yep,
Okay.
yep, you're 100% correct. We have the exact same answers, basically. On the test or something, I would say round to the nearest tenth or 100th. Just be careful on what I ask you to round to, but you are 100% correct on that one. If you look at mine, I actually erased the 2.5 and I just went to the tenths, just because what tells you whether you need to round or not is how important the data is. And the data really, 0.05 wouldn't really affect my outcome, so I just left it as the 10th. Other questions on the homework? I will tell you, you do need to know how to read this. You do have to be able to convert a frequency chart to find the mean. And you will have to know how to find your central point, because it's really the only way to do this one. Because it's really hard to count inwards on something with 96 data sets. Points. Because you would have to go, okay, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. You know what I mean? Like if you're counting in, you have to know how to do this. So this is a good question to know. In fact, why do you think I have that star? Because it's a good one to put on a test, because you really have to understand what median is, and you really have to understand what frequency is. So this is a really good one. I'm not saying it is on the test. We haven't even finished writing the test, but this is a good one to pick because there's a bunch of information there, and either you study your notes and know how to do this, or you don't, I guess. All right, but are we good otherwise? Other questions? Guy in the back. All right, no, all right. There was no one in the back. All right, let us start off with something we've already covered. We said, when we started off, we said statistics has two main branches, and that is descriptive and inferential. Let's break this apart even further than we did on that first day. Descriptive is a brief descriptive coefficients that summarize a given data set. So descriptive, we've already talked about those yesterday. Some big ones we did were mean, median, and mode. We also did yesterday, we did box plots. Box plots would be a definite descriptive statistic. Today we're going to talk about histograms. And we're also going to talk about a stem and leaf. Further down the line, we're going to talk about, let's just call it standard deviation. All standard deviation is how spread apart is our data. How far apart is our data? How dependable are we on this data? Because if I was a basketball player and one game I shot 1, the next game I shot 21, next one I shot 2, then I shot 15, then I shot 3, then I shot 20. I'm not a very consistent player. I could score a lot or I could score a few. Versus someone that scores, 10, 10, 10, 11, 9, 10, 10. That's pretty consistent. But we'll talk about that in the future. But these are all descriptive. These are all charts, numbers, and things that we put on our piece of paper that we then read. And we read them, and then we get an idea of what's happening with our data. Hey, this basketball player is really good. This basketball player is really bad. This basketball player is really consistent. This basketball player is not. Inferential is when you take kind of sample subgroups used to conclude information on an entire population. So basically, when you're doing inferential, you're trying to go from a sample to be able to conclude something about a population. Most of the time, you're going to use probability. Kind of like 95% of people prefer brand A of these crackers. So we're going to keep making more of these crackers. So we typically use probability. And the last thing we're going to talk about is we use hypothesis testing. We probably won't get to this in our class because that's pretty in-depth into statistics. But hypothesis testing is, I think most people will like this brand versus this brand. Now let's come up with some descriptive stats that prove it, and then I'll read those stats and see if my hypothesis is true or false. All right, so we have descriptive and inferential. Now we're going to go further into this. We're going to go further into statistics. So those are our two main branches, but we can break kind of our descriptive stuff into two variables. Two types of variables, I should say. So a variable is a measurement that can change from one item to the next. We have two huge types of variable, and that is categorical and numerical. Categorical are ones that we generally put names to. Color of balls, color of your hair, your feeling that day. I'm feeling happy, I'm feeling sad, I'm feeling bad. Stress level, high, low, or medium if we put words into it. Dog breeds, those are categorical. Numerical, now be careful when you're thinking about this. So their variables are numbers. Just because it's a number doesn't mean it's numerical. In order for it to be numerical, it has to be some sort of measurement using numbers. So numerical must be some kind of measurement using numbers. For example, when we speak of the population of a city, we are talking about the number of people in a city. I'm measuring the size of the city by number of people. So population would definitely be a quantitative variable. Numerical variables can be classified into discrete or continuous. Before I get into that, real quick, two other names. Categorical is qualitative. Numerical is also called quantitative. You'll notice in your homework, I kind of go back and forth on those names. So you just have to make sure you're looking at the right thing. 90% of the time, if it's a number, it's numerical. But if it has a name, it's going to be categorical. In order for it to be numerical, I'm going to say it one more time, it must be some sort of measurement. It has to be a measurement. All right, discrete. Discrete is a variable that can only take a certain number of variables. I think of it as being like steps. You're going up a step. So, for example, number of desks in a room. You have to have a fixed number of desks in a room. Right now I have 18. If I bring another desk in, I have 19. Then I have 20. I'm never going to have 19.01 desks in my classroom. It has specific steps. It goes 1, 2, 3, 4, 5. So maybe students in a classroom. Age is most likely discrete because we always say we're 16.37 years old. What do we usually say? Just we're 16, we're 15, we're 14. So depending on how you use it, age can be discrete. So let's put that in there. Age is generally a discrete statistic because we go by years. You're 1 year old, you're 2 year old, you're 3 years old. Can anyone think of any other discrete variables where you definitely go up by 1 or down by 1 or there's no gray area in between? Sangha.
Every year.
Every year?
Yeah. Like it goes like 2000.
Oh, grade.
I mean, grade, yeah.
Oh, or year?
Or year.
Grades. Yeah, your grade level. Let's go with that.
It works.
Yeah. If I'm a statistic person, I'm not going to interview people that are in grade 9.5. I'm going to interview someone that's in grade 9 or grade 10. What was that? How many pets you have? All right, the next one is continuous. Continuous is a variable that has an infinite number of possible values. So when I measure your, let's say, height, you continually to grow. Like you don't, I'm not, when you grow, you're not like, oh, I'm 50 inches. Oh, now I'm 51 inches. Oh, I'm 52 inches. There's lots of gray area in between. You can be 50.0001 inches. You could be 50.1 inches. You could be 51.035 inches. So it's continuous. There is no, you're not going upstairs. You are gradually growing up. So height is a perfect example of that. Weight also works.
Weight can go down though.
What was that?
Oh, weight can go down, right?
Weight can go down.
I still continuous then?
It's still continuous because you can continuously go down. Like you don't gain a pound, right? You gain maybe 0.5 pounds. You gain 0.4 pounds. It's not something that all of a sudden I'm like 1 pound heavier, 2 pounds heavier. You know, there is points, there's decimals to this. So generally speaking, if you have a bunch of decimals, that is something that's going to be continuous. All right, let's go down below and let's categorize each of these 6. The first one says number of phone calls received. We have to determine whether this is numerical, categorical. If it's numerical, we should put if it's discrete or continuous. So I have number of phone calls received in a day. Is that numerical or is that categorical? Labib. Numerical. It is numerical. Is that going to be continuous or is that going to be discrete? It's going to be discrete, yeah. Because you can't receive 1.001 phone calls, right? You receive 1, 2, 3. Discrete are steps, defined steps. So this would definitely be discrete. Eye color, categorical or numerical? EJ?
Categorical.
It is categorical. Number of Instagram followers. Anything like me, you're up in the thousands probably. Right? That's... All right, Instagram followers though, is that numerical or... I don't even have an Instagram. But is that numerical or categorical? Sangha?
Numerical.
It is numerical. Would that be continuous or discrete? It would be discrete. Yep. Yeah. Weight. Well, that one's pretty easy because we just did it above. But is it numerical or categorical? Is weight numerical or categorical? Emma? Numerical. And would that be continuous or discrete? It'd be continuous, yep. Zip code. Zip code. Is that numerical or categorical? Zip code. Is that numerical or categorical? Jacob.
Categorical.
It is categorical. Whew. You crushed it. Who thought it was numerical? I would have. I would have if I first learned this. Jacob, do you know why it's categorical?
Because there are multiple people under the same zip code.
Well, it's not just that. It's not a measurement. It's not a measurement. It might as well just be a name. It would be like if I walked in here and picked a number to call each and every one of you. So Krupa, you're 23. All right? Zizer, you're 53. And those become your names. They're not measurements. I'm just randomly assigning it. Becomes your name. Zip codes are realistically just the name of the area. And the reason why they're numbers is because they're easy to read by computers and they're quickly read by people. Rather than having to read Milwaukee and how sloppy people write stuff, it's much easier just to write out numbers. So that is its name. It's not a measurement. It's a name. So if we're 53005, I forget where we are. Yeah, there's a 4 somewhere in there. But there is no measurement. They didn't measure how many people are there, and then you get a zip code assigned because you have this many people. It's not a measurement. It is, in fact, categorical. It is a name. 40-meter dash time. 40-meter dash time. Someone new. Krupa. It is numerical. Would that be continuous or would that be discrete? Yeah, it'd be continuous. Because we could do it in, what's a good 40-meter dash time? 6 hours?
Yeah. It's how fast.
How fast you can run 40 meters?
Well, I know that, but like I can't picture how long 4 meters is.
It's like picture 10 meters and multiply it by 4. All right, let's say it takes you like 15 seconds.
No, 7. No, under 10.
Under 10.
7, 6.
For 40 meters?
I would say
I'm
5.
supposed to get 6 or 7.
Okay, so let's say,
5 seconds.
okay,
Either
5
6 or
seconds.
7 seconds.
But if this was discrete, it'd be like 5 seconds or 6 seconds. When you have races, does it come down to the second? Or does it come down to
7.79.
like the hundredths of a second? So that's why it's continuous. All right, let us continue on. We're going to talk about 2 charts that look very similar to each other but are very different. And that is a bar chart and a histogram. All right, our bar chart, guys, our bar chart. A bar chart is made up of columns plotted on a graph. Each column represents a group defined by a categorical variable. Sometimes it can be a discrete one, but usually it's just categorical, whose height indicates the size of that particular group. Bar graphs generally have a gap between adjacent bars. So that's how you know it's a bar graph. You have a gap between them. So once again, your big thing is it's a categorical variable goes with bar chart. On the homework, I'm going to give you some information, and you have to determine whether you need a bar chart or a histogram. We'll talk about a histogram in just a second. Note, you have labels on a bar chart. I have a name. I'm less concerned about the name, but I'm very concerned about your x-axis being labeled and your y-axis being labeled. So this one is, we got categories of countries, and this one we'd have dollars. Note the gaps. Let's go ahead and make a bar graph on our own. We're going to do pets. I heard pets before, so we'll do pets now. Who has a pet? What kind of pet do you have?
I have a dog.
A dog. All right, we'll start with dog. How many people have a dog? 1, 2, 3, 4,
No, he used
No, I'm just kidding. I never.
5. Guys, we're taking up time. This is homework time. So we have 5 people that have pets or dogs. So we will count up 5. 1, 2, 3, 4, 5. And we have 5 people with a dog, and we'll go ahead and do a bar. Who has a different type of animal that's not a dog? EJ.
I got a goldfish.
A what?
A goldfish.
A goldfish? So we'll just put fish. Who else has fish?
I don't have fish.
So that's 2, 3. So we have 3 people that have a fish. All right, what other pets we got? Songa.
I have chickens.
Chickens.
Yes, I do.
Korea.
I do.
In Korea?
Yeah.
Here.
I have cows.
Korea.
So you guys,
Chickens.
yeah, mine aren't in the U.S.
All animals. Who has chickens for pets? Not that they have a farm, but who has chickens for pets, I guess.
What was
I
my
had
name?
chicken yesterday.
We'll just put 1. Just for the graph's sake, we'll say 1. What other pets do we have? We'll do one more. Cat. Who else has a cat?
Oh.
I have a cat.
Asher, you
Do
do.
you really?
Yeah.
Asher doesn't.
Asher
Your
does.
coolness just went down.
Asher does big fat.
Or it went really high. All right, guys. All right, so we have. Let's make sure we label this. This is where we are pets. And maybe 1, 2, 3, 4, 5 would either be the number of students that do, or we could just go frequency. So either you put number of students that have it, or you can put frequency. I labeled everything. It's got a title. It's got things labeled there. Are dog, fish, chickens, and cat, are those definitely categorical?
Yes.
They're definitely not numbers measuring something, are they? So those are going to be categorical. And that's it. That's a bar chart, categorical. All right, histogram. Histogram will not be categorical. Histogram will definitely be numerical. You only use histograms for numerical objects. Most of the time, they're usually continuous, but they can be discrete as well. Usually, anytime we're using numerical, we're going to use a histogram. So histogram is going to be with quantitative, which is numerical. Remember, quantitative is numerical. Note, do we have any gaps? No. No, we have no gaps when we're doing a histogram. It makes things a little nicer. It makes things a little neater. Let's put some information down on this. Typically, when we have histograms, our up and down is usually our frequency. How often does something happen? And if you look at these, see, this is 3 to 350. This is 250 to 300, 200. This is really just a frequency chart. We did frequency charts. We've done frequency charts. This is a frequency chart just turned into a graph. So these have class sizes too. So let's look at that little box right there. For frequency charts, we call this a class size. We could still call this a class size, but more often than not, we call it a bin. We create these bins, and we see how many things we can put in these bins. So I create a bin that's 250 to 300, and I say, guess what? I can put 50 items in that bin. From that data, there's 50 of them that appear. Now we're going to lead to the hardest question. Yeah, oh, sorry.
We still label these, right?
You still label these. Yep, these are still graphs. If you notice, this is exactly what we have. We have height, we have our trees, and we have our tree height. So you should be able to look at this without reading anything above and generally get an idea of what's happening here. So we have tree heights. Oh, here's our heights. Here's the number of trees that have that. The problem with histograms is, what do you do with those numbers that are right smack dab in the middle of classes? In other words, this question says, what interval would a tree of 150 centimeters fall? So if I have a tree that's 150 centimeters and I need to add it to this graph, would this one increase by 1, or would this one increase by 1? Which one are you thinking? Both of them? Can't be both, because a bin can only have one item in it. EJ?
No, I don't know. I'd probably say the right one.
The right one. So if I'm facing you, you would say this one?
Yep.
You'd be correct.
Good job.
You would be correct, because bins, this bin is actually 100 to 150, not including 150. So if you think about this, this would be 100 to 149.99999. So the easier way to write that is, well, it's any value that's between or equal to x and less than 150. So it doesn't include 150, but it would include 100. So the lower number always goes into the bin to its right. So if I add a 150 centimeter tree, I would add it to this one. If I had a 250 centimeter one, I would add it to this one. That is how histograms will always work, unless it specifically says otherwise, which it'd be really weird if it did. That would be just a wrong kind of graph. Now, real quick, we aren't actually doing a histogram together because I think you guys can handle this with frequency charts. It's basically a frequency chart where we create our bins and we count up. I did want to point out one important fact. Look at those graphs. Jacob, look at the graph. Look at the graph with us. Does it start at 1?
No.
they don't always start at 1. In fact, if I started with 1 on this one, I'd have all this blank space where nothing's happening, and then also have a little section where a bunch of stuff happens. So create your class sizes, and on the homework, I think I tell you the class sizes to use. There might be one where I say come up with your own class size. But generally, I'll give you your class size. Find your smallest value, and that's where you're going to start your histogram. Don't start at 0. Start at where you need to focus in on it. Yeah, so
So what happens? There's 1 through 5, and then now you have 100 through 150.
then you do have to put all that down. What you can do, and we're not really getting into that, but what you can do in those circumstances, I won't make that happen. But what you are allowed to do is, so Songha's saying, what if we have a value between 0 and 1? Maybe it's up there. Songha, I'm answering your questions. Let's pay attention. All right. So let's say I now have to go up to 150, but I don't want to actually have to write all that. What you can do is you can put a little double dash, saying you're skipping a bunch, and then you could have 100 and 105. Sometimes they put a little Z in there, but you make a little mark saying we're skipping stuff. Yep. Yeah.
So would the frequency always go on that side?
The frequency would almost always go on this one. Yes, because that will be our. So this is our dependent, our independent, and this would be our dependent. It depends on which size we're looking for. Yeah, frequency is always going to go up. All right, the last thing we're going to talk about is a stem plot, which is also known as a stem and leaf plot. Stem and leaf plots are generally used to show data sets that are relatively small. Even 50 is a pretty large one to put as a stem and leaf because you are still listing all of the data. We are just condensing them so we don't need to write the same numbers over and over and over. Well, let me show you what's happening. So below is a stem plot showing the test scores of 20 students. Now, a student didn't get 2%. They didn't get 4%. They didn't get 6%. Instead, they got a 52%, a 54%, a 56%, a 58%. So if we look at these leaves right here are actually going to equal your N, your number of data. Remember, N is always your number of data. So once again, there wasn't a 2, 4, 6, 8. There was a 52, a 54, a 56, a 58. There was a 61, a 65, a 68, a 72, a 74, a 74, so on and so forth. In fact, when you have a stem plot, most of the time they put a key. Either they put a key to the right of it, or they put a key to the left of it. Let's go ahead and put it to the right of it. So we'll put a little thing that says key. And the key will generally have one value that actually exists. So let's pick 65. So they'll put 6 and 5. And they would say something like, that's my 65%. So the key lets you kind of know how to read it. So a key sometimes is in place of having a nice title and things laid out. It's always good to put like student test scores up here, but this key can help you without having to say that these are percents. This will say, read the key as 65 equals 65%. Because there are times where you'll have a 65 and that's actually 6,500. Because you didn't want to have to write 100 over and over and over again. All right, let's create a stem and leaf plot for these heart patients that are getting their blood pressure measured. So we have a 45, a 56, 60, all the way. It looks like my minimum is a 45, and my maximum is an 83. Now, it's not a bad idea to put them in order, especially when you have like a ton of data, but there's not too much there, so we're going to go ahead and just leave it in the order that it has. So our stem, we said the lowest one is 4, 5, 6, 7, 8. Our biggest one is 8. All right, so what I would do is I would look at my 40s. We have a 40 here. That's the only one we have. So we're just going to put a 5 there. Then I'll circle my 50s. So we have a 56. We have a 59. We have a 52. And we need to write these in order. So it must go 2, 6, 9. Then I'll go ahead and cross those out. Now let's look at sixes. So sixes have a 60, a 62, a 60, a 65, a 67. So that means we need to have a 0 twice. You're going to list both zeros because it's a 60 and a 60. So I'll go 0, 0. Then we have 2, 5, 7. Then we have a 79. We have an 82. And we have an 83. I do want to talk real quick. How would I find the median? How would I find the median without actually having to write all these out again? EJ.
Well, you could just count the number of leaves
Yeah.
there are.
Yep.
And cut it in half.
And kind of cut in half, right? So when we're looking for our central point, we do n plus 1 divided by 2. So if I was trying to find the median, if I ask you to find the median of this first one, what I do is I would do n plus 1 divided by 2. Our n is a number of leaves. We have 20 leaves, so that'd be 21 divided by 2, which equals 10.5. Then we start in either direction and count 10.5. So let's go from the start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.5 would be right here. So what would our median be? It's right between 74 and 74, right? Because we said it was about here. That would be our 10.5. So what's halfway between 74 and 74? 74. So 74 would actually be, not 44, but 74. All right, questions on stem plots. All right, then really quick, we talked about histogram and bar charts. Big difference is bar charts have gaps, and they use categorical data. Histograms do not have gaps. They have classes called bins. Make sure you label everything. Then we went over numerical versus categorical. Also know the terms quantitative and qualitative. Categorical is usually the easier one to see because it's just names of items. It's usually words. Numerical must be a measurement. It must be some kind of measurement. And we started off with descriptive and inferential, but we've already done that before. All right, if there's no questions for me, if you could quickly have out